For question 8, what is the limit of h of x as x approaches -5 from the right? So as it approaches -5 from the right, that would be the limit of x approaches -5 from the right is 20 minus x squared. So we just plug in -5 into x. So that would be 20 minus 25. So the answer would be -5. For B, as x approaches -5, what is the limit of h of x? So to find the limit as x approaches -5, we would have to check if it is equal from both the left and the right. And from part A, we already got the answer from the right, so we would just have to check for the left, and that would be the limit as x approaches -5 from the left is negative absolute value of x, so this would just be -5. So as x approaches -5, the limit of h of x is -5. What is the function of h of 3? From this we can see that 20 minus x squared is equal to 3, is less than or equal to 3. So this means that it would just be h of 3 is equal to 20 minus x squared. We plug in 3 for the x. That would be 20 minus 9. It is equal to 11. We already found the limit of h of x as x approaches -5 from the left from part B above, and we know that that is equal to -5. E, what is the limit of h of x as x approaches 3 from the right? Well, from this number line, we can tell that from the right, the limit of x approaches 3 from the right is equal to 4x minus 1. We can just plug in 3 for x, and that gives us 11. To see if the limit of h of x as x approaches 3 exists, we need to find if it's the same number as it approaches it from the left and from the right. We already found from the right, so now we just need to check the limit of h of x as x approaches 3 from the left, which would be 20 minus x squared is equal to 20 minus 9 is equal to 11. So since it's the same value from the left and from the right, the limit of h of x as x approaches 3 is equal to 11. H is -5, but we can see from this that it is just the negative absolute value of x. So this would just be -5. And from part F, we already found x approaches 3 from the left, and we know that it is equal to 11.